Hey, it's Gab, your trusted power system protection geek.
Do you ever wonder how our power systems continuously operate and supply electricity to our homes despite harsh conditions and faults? How it protects itself from unexpected catastrophic incidents and major damages? Well, that is where our hero Protective Relay comes to shine. In this video, we are going to learn about protective relays and how crucial its role in the protection of power systems.
Protective relays are vital components of modern power systems. They play a critical role in ensuring the safety and reliability of electrical systems by detecting and isolating faults that could cause damage to the system or cause harm to people. Protective relays are used to monitor various parameters such as voltage, current, frequency, and power factor. And when abnormalities are detected, they activate the circuit breakers to isolate the faulty section of the system.
Now, we have an idea of what protective relays are, but what are their functions?
The primary functions of protective relays are to detect abnormal conditions and initiate corrective actions to minimize the impact of faults on the system. These abnormal conditions could be caused by various factors, including short circuits, overloading, and insulation failures. Once a protective relay detects an abnormal condition, it sends a signal to the circuit breaker, which isolates the faulty section of the system, preventing major damage to the equipment.
I also listed the specific functions of protective relays for us to truly grasp their importance.
First is the removal of the faulty component. The component which is behaving abnormally will be promptly removed by triggering the trip circuit of the circuit breaker or by protective relays acting as an alarm. Second is the damage mitigation to the rest of the system. It is the disconnection of the abnormally operating part to avoid the damage or interference within the effective operation of the rest of the system. Third is the fault localization. Protective relays restrict the spread of the effect of the fault so that there is none to minimal interference will be caused to the rest of the healthy system. Thus, by disconnecting the faulty part, the fault effects get localized. Lastly, the fourth is the system improvement. It improves the system performance, system reliability, system stability, and service continuity.
To fully understand the nature of protective relays, here are some key terms to remember.
First, pickup level. It is the minimum value of current or voltage at which relay responds and starts to operate. Second, reset level. It is the value of the current or voltage below which the relay opens its contact from its closed position and comes back to its original position. Third is the operating time of relay. It is the time which elapses between the instant when actuating quantity exceeds the pickup value to the instant when the relay contacts close and return to its original position. Fourth is the reset time of relay, the time which elapses between the instant when the actuating quantity becomes less than the reset value to the instant when the relay contacts return to its normal position. Fifth and the last is the reach of relay. It is the impedance of the transmission line up to which the distance relay protects the line from fault. The tendency of a reach of distance relay to operate at impedance larger than its setting value is known as overreach, while the tendency to restrain at the set value of impedance lower than the set value is known as underreach. Protective relays are truly amazing and useful protective devices. This concludes our video. I hope you learned a lot and I'll see you on the next one.